Hello everyone and welcome. Since we're past the halfway mark on the course, I'm going to circle back around and start talking about some of the earlier modules, and we'll go back to the beginning with Module 1. Some have still to turn that in, so hopefully this review will help with that. So I'll go over this fairly quickly and try to focus some of the time on some additional considerations, such as maybe a interactive sort of doing it and letting you see what I'm doing. So jumping straight in, the agenda for today, we'll talk about Module 1 and Deliverable 1, including R and Python and the variations on that theme. So jumping into Module 1, it's all about setting up an analytics environment. The purpose of this is so that you have a place to do your work. Without an analytics environment, it's hard to do analytics, right? So this is relatively straightforward, but you do also need to follow through on the deliverables because there's like a few more parts to it. So jumping in, we're going to talk about the setting up the environment and the process you go through. We'll start with Python, then we'll move over to R. Also then we'll talk about Deliverable 1, where we talk about the documenting the various pieces. Most people that turn something in did pretty well on the first two, fell down a bit on the second two. So there's a total of 4 items there to consider. So in Python, the best way to get it installed is, generally speaking, go with Anaconda. It's relatively straightforward to do. And we'll go over that and then talk a little bit about packages, installation, management of those packages, and then pip and conda. So to start the process, go to anaconda.com and then pick the appropriate installer for your environment. So you do, generally speaking, want to stick with a 64-bit unless you have a really, really old computer, which if you do, I feel for you. So generally speaking, you want a 64-bit installer and pick the one that's appropriate for your operating system. Whenever you go and run that, in the case of especially Windows, you basically are prompted with a setup sort of thing asking, hey, do you really want to do this? And do you accept the license? You click yes. Generally speaking, you want to say just for me. Because if you don't, then you're going to have to deal with an administrative prompt sort of thing. Not the end of the world, but generally speaking, most of the time, it's one person on a computer anyway. So to keep that in mind. Do not add the Anaconda 32 to your path, and basically it's just clicking through. It's really straightforward, and once it finishes, you'll be told about, hey, there's this thing called PyCharm. Do you want to install it, or click on the link to learn about it? You really don't need it for this course. You may or may not have an interest in it for yourself, but it's more around people doing professional Python development, not so much data scientists. So if you're writing sort of applications and such with it. The next thing is to go and make sure it actually really installed. You do that by going to a command line and just type Python -- version. And if you see something similar to what I have on the screen there, 3.8.3, then guess what? It was installed. And you also want to do that by going through the Anaconda prompt. That's a key sort of navigational thing, is that these areas are where you can basically interact with Anaconda or Jupyter. I strongly recommend you embrace Jupyter. It is a cool way of doing your data science work, and it's also how most people do it these days. To verify that Jupyter actually worked, you click on the same sort of thing, click inside of the Anaconda folder that was just created, click on Jupyter Notebooks, and this should pop up. And so basically this is a navigational construct, lets you navigate just like you do a file system with Windows Explorer. And you can do simple things like creating folders, creating notebooks, and so on in that environment. To do that, you click on something like new here and say that you want to create a new folder. You give it, it comes up with the name of untitled folder. You have to then click on that folder here and say you want to rename it up here, and it prompts up asking you, what do you want the new name to be? It's a little weird because you normally, whenever you create a folder, you want to give it a name, but if you think about what Windows Explorer does, it's very similar. It's just that it's a bit easier to do because there's a few less clicks. The next thing you might want to do is navigate to the new folder and then go in and potentially add a notebook. So you, in that same sort of UI, you click on new and then you say Python 3 for the type of notebook you want to add, and there's this notebook Python 3, and it pops up an empty notebook. Again, no name, so you have to give it a name if you want it to be something more interesting than untitled. You can then execute code inside of your notebook by clicking into the cell and typing in something. And again, this is one area where a few of the deliverables were a little short. It needs to be something a bit more complex than what I've got on this screen. This is the simplest of things. You might want to find some sort of mathematical formula that's being done. Fahrenheit to Celsius is kind of the low end of the scale as far as complexity goes. You want something a little more complex than that, but to show that you have some sense of what it's doing. Basically, it's got to be more than just the simple sort of hello world. A key thing to understand with Python or with Anaconda notebooks, Jupyter notebooks, is that your cells can have a different type. They default to code whenever you create one. You can switch them to be something called Markdown, which is a way of doing a pretty sort of visual of the contents that you want to do. That's perfect for things like comments and code, so that you can see what happened and basically have it towards a unified, almost like a web page sort of experience, blended in with code. There are several ways that you can install libraries, and libraries are essential because they basically are how we extend a language. And in this case, it's how we do things like plotting and loading files and a few other things. The simplest for somebody new to the environment is to use the Anaconda environment. If you're more experienced, you're probably going to do something like pip. And so those are the ways that you typically do it. To walk through what those look like, whenever you do it with Anaconda, you oftentimes do it at a command prompt. And so you can go in and basically type in conda install and then the name of the thing you want to install. And in this case, you can see that the matplotlib is already installed. You similarly can do the same thing in the UI by going into the Anaconda Navigator. Click on environments here, navigate to the one of interest. In this case, there's only one, which is the base or the root environment. And then you can search for a particular library, and you can switch this between all or installed. And you can see here that it is installed and that we've got version 3.2.2 installed as well. Another way is to do it inside of a notebook itself. So if you have conda install and then the library inside of a cell inside of a notebook, and generally speaking it needs to be the only thing inside of that cell, then that is another way of doing it in a very similar approach to doing it a command prompt. The advantage of that approach, if somebody gets your notebook, they don't have to do anything special to make it work. There's other ways to do that you'll learn later, but that's the simplest way. Another way is to do pip. Pip and conda are kind of similar in nature. The biggest difference is conda is specific to the Anaconda distribution, where pip is more central to Python. The syntax, though, is virtually the same: pip install and then the library that you want to install. And you can see here that it does show you a bit more information than conda does, because it's actually looking at the dependencies. So oftentimes one library refers to another. That's what you're seeing here, is that it is dependent upon these other ones. And so it's also checking not just that matplotlib is installed, but everything that it needs is as well. You can also do the same thing inside of a cell inside of a notebook. So you can do pip install and matplotlib inside of a notebook and do the same basic thing. Whenever we talk about R, it's kind of a little, there's two ways you can go. The easiest way is to install it through Anaconda. That's probably the easiest way. And all you have to do is click on to the Anaconda Navigator and click on install, and everything gets taken care of. The other approach is to download it yourself. Basically, there's two components to R. There's RStudio and R itself. RStudio is the UI that you use. You download it by going to RStudio and then clicking on download. Pick the appropriate license you want, which in this case is the RStudio desktop. You don't need server, and you certainly don't need to pay for anything. And click on download. Pick the operating system that's appropriate for your installation, and then run through the installer. Once you finish the installation process and start up R, it would tell you, hey, you don't seem to have R installed. Do you want to install it? And so the solution there is to go to the rproject.org page and click on download R. Pick a mirror that it's closest to you, probably geographically as good as any, definitely something in the same country. And then go through and click on R for Windows if you're installing Windows. And then if you're wanting to install it the first time, you can say install R for the first time. You click on that. It gives you then something to download. You basically click on it and download it. Once it gets done, you'll have to go and open up that downloaded executable. In this case, it's r-403-win, and run that and basically click through it. It's pretty straightforward. Nothing terribly different here. It's pretty much accepting the defaults. And at that point, if you launch RStudio again, this time it doesn't tell you, hey, you don't have R installed. And then whenever you're dealing with R, you also will likely want to install packages because the ones that come there may not necessarily be. It's got a less robust environment than perhaps some of the environments like Python does, but still there's quite a few available. The difference here is inside of the RStudio environment, you click on Tools, Install Packages, search for a package of interest, and then basically install it. And so that's the process of getting RStudio and Python up and running. The key thing here is to be taking screenshots as you go through this process so that you can then put those inside of your Word document to show that you've got it installed. Moving into the deliverables, deliverable 1, the instructions is to basically get it installed. And as you're doing so, you want to demonstrate R programming. And then you want to do so by also doing some plotting using Lattice and ggplot. And also do some matplotlib, pandas, and numpy programming as well. The rubric, and this is where you want to make sure you follow each one of these. So successfully install NumPy, matplotlib, which with more sophisticated graphs using more advanced graphing features, successfully converting to and from NumPy arrays to each other, and Python data types such as lists. So make sure you read all of this rubric because that's what I have to go by. And if you miss some of this, I will give you the appropriate grade and kick it back. Generally speaking, you want to shoot for mastery on all this. So also taking a look at the next one, successfully installation of Python and Jupyter notebooks with significantly more sophisticated programming using more advanced programming features. See, so the proficiency is basically saying it's more advanced than Hello World, but it's basically somewhere around Fahrenheit to Celsius. So you need something more complex than Fahrenheit to Celsius for this to get over into this column. When we talk about R, similar experience, successful installation of R libraries, Lattice and ggplot2, and then you also do some more sophisticated graphs using more advanced features. And through here, you're basically using the default settings. You're getting into the more customization over here. And then at the very top one, successful installation of R environment in RStudio and with significantly more sophisticated programming using more advanced programming features. And again, something more complex than Fahrenheit to Celsius. So it's got to be a bit more than just a single function. Feel free to take a look at your second deliverable and maybe think about that kind of code as some way of satisfying this requirement. So with that, I finished the conversation around module 1 and deliverable 1. And in the background, as soon as I can find the window, I've been spinning up a virtual machine so I can run through the installation. You don't have to do this on a virtual machine yourself. The reason I'm doing it this way is because my desktop, as you can probably imagine, is pretty convoluted. Lots of stuff installed. It's not letting me. Apologies. Things are kind of froze. There we go. And what I'm trying to do here is authenticate. Here we go. With a different user. It's taking a bit. One thing that you may want to do as a way of addressing the more complex than Fahrenheit and Celsius is to take a look in some of the resources that are available to you as a student at the University. If you take a look and as long as you attribute what you're pulling things from, I'm perfectly fine with you going into a resource such as O'Reilly's. So Learning O'Reilly Home, searching for something like Python code examples, and then as long as you attribute where you got it from, perfectly fine with me. Trying to figure out why we're crawling here. Here's why. Again, give me one moment. Try that again. So again, if you go in and do something like Python code example or code cookbook, that's probably a good one. And do make sure, though, that if you do this, you attribute your source, and probably try to change it up a little bit if you can. So you may want to take a look at some sort of examples of working I'm trying to think of something that's appropriate. Well, hopefully you get the idea of basically pick something that is interesting enough that you can modify it, make it to where it's kind of your own thing. And this is how it usually goes whenever you go off script. Yeah, well, that's not working. So we'll table that because that's not going. So another approach that you might be able to do is Python code example complex formula, and as long as you attribute where you get the information from, I'm perfectly fine with you taking examples of this as long as you understand it. Keep in mind this right here, this will cause you some grief because this is Python 1 Python 1 syntax. So you'll have to be cautious if you go that route to make sure you'll get it to work. And these are not terribly good. But the basic idea is to find a formula, and maybe it's, I'm trying to think of something of sufficiently complexity, volume calculations or other sort of calculations might be useful. But basically the idea is make it interesting, make it more complex than Celsius to Fahrenheit or Fahrenheit to Celsius. And basically that's the challenge and goal. So again, the key takeaway, if nothing else, is go by the rubric. It is your guide. If in doubt, that is what you want to take a look at. And if you have any questions about what the rubric is meaning, do ask. And I provided what I believe to be fairly detailed instructions and feedback in your rubric. If you have questions about the feedback, let me know. I purposely try to be as fair as I can. So if something you feel is unfair, if I overlooked something, point it out to me. That's the goal here. This is a collaborative effort. I'm here to support you and help you be successful in this course so that you can be successful in the ones that come after. If you have any questions about the material I've talked about today, let me know. Stay safe, and we'll speak again next week.